So in these two examples, we are going to be solving exponential using logarithm. Okay, so previously, before you start logarithm, there's this section that we spend some time on exponential equation. So in E math, we got exponential equation. In A math, we also got exponential equation. So by the time you are here, you are not new to exponential equation. So in E math exponential equation, you actually make same base to compare with the power. Okay, but in A math exponential equation, you mostly you are also using indices, but you are using the method of substitution. So right now you already learned the idea of logarithm. So there can be some exponential equations that we use logarithm to solve. So I'm going to show you the method. Okay, and then later on you will decide uh, which method that you prefer. So for example, if you look at 6a, it's a exponential equation is e to the power of something. Okay, so the x is hidden in the power as usual. So for all our exponential equation, the x is hidden in the power. Okay, so I'll show you these two methods first, then you decide which one you prefer for yourself. So for example, method one, okay, method one is to take ln both sides. That means, right, I introduce ln on both sides. That means you insert ln on both sides. Okay, so for this method, you can only insert a ln on the left and you can only insert a ln on the right. You cannot insert two ln. So it's like taking ln on each side, one ln on each side. So why are we doing this? Because ln is a form of logarithm. Once you introduce a log, the power can be brought down. According to rule number 5, the power can be brought down. And if you still remember, so that is log base E. So this part is the same as this part, which is like your rule number 1 in logarithm. Okay, so you can relate it to rule number 1 or you can punch calculator. You punch calculator ln E in your calculator, it will also give you a value of 1. So in fact, you are left with 2x plus 3 bracket 1 equal to ln 6. So put it simply, so this is ln 6. And ln 6 is actually a value that you can punch on your calculator. So what you can do is you slowly move it over and you divide by 2. So if you punch calculator, okay, you will get minus 0.604. So that will be method 1. Method 1, you can take ln on both sides. Okay, so personally, I do method 1. Okay, so there is also another method. Okay, the other method is you change this to your logarithm format. So do you still remember? So so this is log E, the base is E. The answer is 6. The power, this is the power. So some people will prefer this method. So that means you change it to the logarithm format. Like the first time you learn logarithm. So in teaching worksheet number 1, you learn to switch in between indices and log. So you can do this. So if you do this successfully, you get a log 6. So if you do it successfully, right, directly, this part is the same as this part already. Then from here, you can slowly, 2x will be ln 6 minus 3. Then back to the same thing. So some people prefer this method. So I let you decide. It's fine. So whether you like to do this method 1 or method 2. Okay. So in the next one, is a base 10. So because this is a base 10, I can also take LG on both sides. So the unknown is in the power. So method one, okay, I will introduce LG on both sides. So previously we introduced Ln because it's the exponential, it's e to power of something. So in this case, I'm going to introduce Lg. I'm going to introduce Lg and I can bring down the power. And this part is a value 1. You can punch calculator or you can see as log 1010. So you get this. So y will be this value. Then you can punch calculator. So you get 0.398. So method 1, you take Lg on both sides. Very similar to the previous one. You take Ln on both sides. But method 2, I can change to the logarithm format. So if I change to a logarithm format, it is a base 10. The answer is 14. And the power is 1 minus y. So that means this part is Lg 14, 1 minus y. And y is 1 minus Lg 14. And then you still get the same answer. Okay, so either you prefer to take ln both sides, or you take Lg both sides, or generally you change it to your logarithm format. Think of it as an index format, indices format. Change back to logarithm, and then you are able to punch calculator. Okay, but again, there will be times that you can't do that. You couldn't do a ln on both sides. Okay, so in such a case, right, you can do a substitution like what you are used to. Okay, so in this case, if you still remember the trick of substitution, okay, you look at the two exponential. The simpler exponential will be your substitution. So I will be letting k equal to ex. Then you got to think about your e2x. E2x is the same as ex with a square. So essentially it's a k square. So if you do the substitution, you will get k square minus k minus 6. So do your factorization carefully. Double check. Okay, so you will get two values. Okay, when you get your two values, that means your ex is 3, your ex is minus 2. So you can change it back to your index format. Okay, so actually you can change it back to the index format, logarithm format, or you can ln both sides. Okay, so I will show you both methods. So for example, in this case, I can do, okay, let me write down the method 1 here. I can take ln on both sides. So ex equal to 3, ln both sides, and you can bring down the power. So you will get ln 3, and you can punch calculator. So do the same thing. Okay, but when you try to do this, the ln minus 2 is a math error. So there's no solution here. Okay, but let's say you decide to do method 2. Then it will be something like this. Because you change it to the base and the power. So it's back to the circular motion. So in the end, you get ln 3 is equal to x, which directly is a 1.10. Okay. So if you try doing the same thing here, you will get this. And actually, it's a no solution also. Because if you still remember, we cannot take log of a negative number. So either way, whether you do a method 1 or whether you do a method 2, the answer is the same. So it's up to you. You decide. You standardize the method for yourself. So the method is the same as like what has been shown in 6a and 6b. Okay, so the next one looks very complex. You realize this one looks super, super complex, but x is still in the power. So how are you going to do that? Okay, you need to gather all the powers together. You need to gather all the power together. So there will be some amount of indices here. So in this case, you look at it as 2x multiply this part is actually a 3 square x. So this part is actually a 3 square x. So that is actually a 9 power x. Okay, remember I said your job is to gather all the x to one side. Okay, so this one, if you still remember your indices rule, there is a rule that account for same power. So when the power is the same, you can make it this way. So I will get a 18x. Okay, then I'm going to divide this over. So when I divide this over, it is also same power. So in your indices, we also have the rule that helps you to deal with same power. So when that is the same power, is 18 over 7x equal to 5. Okay, so by the time you come to this, you are back to either method 1 or method 2. Okay, you are back to either method 1 or method 2. So I'm going to show you both methods. Okay, so I'm going to show you method 1 first. Okay, I will do a LG on both sides. Then I can bring down the power. And this chunk of logarithm is actually a very ugly number. You can try punching from the calculator. You realize that it's a very ugly number. So never mind, you just divide it over and then you just punch calculator. So you get 1.703 SF. Okay, so I show you method 1. So you can also be doing it with method 2. So when you hit this point, you can also do it as a method 2, but it's a bit more difficult. So I got to show you. So if you are doing method 2, okay, you got to change to the base that is stated there. And the answer is a 5. And that is your x. Your x is in the power. So if you change your logarithm method, like method 2, okay, this is what you are going to have. But you remember, we cannot press calculator for this part. So we cannot press calculator unless we change it to LG. So that will require the change of base where you do something like a heaven and earth. But you still get to the same thing. So if you check carefully, this part is exactly the same as this part. That means, right, you will still get the same answer if you punch calculator. So which one is more at ease with you? Do you prefer to directly take a log LG on both sides? Or you prefer to change it to logarithm And because you need to assess the value of it, that's why you need to do a change of base. So whichever method that you prefer, the answer will still be the same. You just need to choose a very comfortable method. Okay, so that's one of the generic thing you got to decide for yourself. Okay, another example is this kind, where your job is actually to simplify something like this. Okay. Actually, this one, right, can be punched on the calculator. Okay, you can punch this on your calculator. If you punch this on your calculator, it will give you a 7. Okay, but if let's say you need to show working, how do you arrive at 7? So I'm going to let the whole thing equal to this. So my job is to find K because I need to know the value of the whole thing. So what I'm going to do is I'm going to use the same method that I have learned here, the taking LG on both sides. So I'm going to introduce LG on both sides. So you'll find a bit weird because when you introduce LG in this way, there's a LG in the power, there's also LG on the ground. Okay, but the reason why we wanted to do this is because it allowed me to bring down the LG7. It allows me to bring down the LG7, and this is the value of 1. So essentially, you get LGK equal to LG7. And if you compare both sides, you get K equal to 7, meaning your K, which is this, is actually equal to 7. But directly, you will have a rate, you will be able to punch on your calculator as well. Okay, so this is just to show you how will you use the exponential technique to find the value. Okay, then this one is the same thing. You can punch on your calculator. If you punch on your calculator, it will have given you a value of 5. Okay, but again, I'm going to use the same method that we have just learned. I'm going to do the subs. I'm going to let K equal to this. And I'm going to take Ln on both sides. So I'm going to take Ln on both sides. And then the whole power can be brought down. And this has a value of 1. So after I successfully bring it down, L ln K is equal to ln 5. And you can compare both sides of the log. So you get K equal to 5. And your K is E ln 5 equal to 5. Okay, so if you need to show, then you do. Otherwise, right, you can actually directly punch a calculator. Okay, but maybe this one, we can't directly punch, but I'm going to use the same method. Okay, let's see whether it works or not. So again, I'm going to let K equal to this. Okay, so in this case, I am going to introduce LG2. I'm going to introduce LG2. I'm not going to introduce LG or LN. So I'm going to introduce LG2 on both sides. And the whole power can be brought down. And after I bring down the whole power, this is a value 1. So I will have gotten, so I can do my same comparison. So when I do the comparison, my K is equal to 9. And what exactly is your K? This whole thing is your K. So you find that you couldn't press calculator because this one is a base 2. So I will still introduce the LG, but I'm not introducing LG. I'm introducing log base 2 on both sides. Okay, so this one, if you are not required to show, you can just punch calculator. You can get a value for it. Okay, so this one is the exponential one. Generally, people will find this difficult. You will need to strategize, choose a method for yourself. So for me, I always do the method one. I always LG both side or LM both side. Okay, but you choose your preferred method. You do it correctly, you will still get the same answer.